Okay, in this problem, which is problem 15.70, it's sort of a long problem, and we have two wheels. We have this wheel right here that we'll call wheel D. We know it has a radius of 6 inches. And directly above D, we're going to have this point A. And A is this link right here. And it's connected to a point B. And then B is on another wheel. And this wheel is E. And this radius is also 6 inches. But we're given some other pieces of information about these distances DA and BE. We're told that the distance AD is equal to 5 inches, and it's completely above A. A is completely above D, so it's just in the vertical direction. And we're told that BE is equal to 4 inches. So this distance right here is 4 inches, and this is directly horizontal with E. And what we're interested in figuring out is what the velocity of this point E is right here. So what's this velocity of E? We're also given the length of A to B, and A to B is it's 14. This right here is 14 inches. So where do we go? One last piece of information we're given is this velocity D. So the velocity of D is equal to 6 inches per second to the right. So this is just in the horizontal direction, and it's just going to be 6I. Okay, so how do we go about solving this problem? Well, we have the most information about this wheel D right here. So we're going to solve for our velocity A. Now A is connected to B, so we're going to solve for our velocity of B, and B is connected to E, so once we get the velocity of B, we can figure out this velocity of the wheel, E right here. This isn't as straightforward as you would think, but we'll just start going. So let's look at a free body diagram, or a kinetic diagram of this wheel D. At this wheel D, we have this point D, and we're interested in this equation, right? We're interested in the velocity of A is equal to the velocity of D plus this omega D crossed with the distance, the position vector from A to D. And we know most of this information. We know the velocity of A is unknown, so we're going to assume it has a positive x component and a positive y component. And this is a pretty long problem, so I'm just going to put it straight into this equation right here. So it's going to have a velocity AXI plus a velocity AYJ our velocity of D, we're told that it is 6I. And we can figure out what this omega D is, what the angular velocity of this is. We know that the velocity of D is equal to omega times r of D, and we know the velocity of D is 6, and our omega is going to be what we're solving for, and we know the radius of D right here is 0.5, or is 6 inches. So omega is equal to this 6 velocity divided by this 6 of this distance, and we get 1 radian per second. Now, we know that we're moving to the right, so in order to move to the right, our angular velocity has to be this way. And now, when we bring it back into this equation right here, because we're moving this way because of the right-hand rule, this is going to be a minus 1k. So this is going to be a minus 1k. And this position vector of A with respect to D, it's this right here. So if we're going straight up, we're going up 5 inches. So it's going to be 5j. Now if we compute this cross product right here, we're going to have a minus 1 times 5 of a k cross j, and this is k cross j is a minus I. So we're going to bring that minus sign out here, and we're going to have a positive 5i. Okay, so this becomes our velocity of A. Now if we separate our I and j components, we have the velocity of A, xi, is equal to 11. Actually, we don't need that I, but so it's just our x component is equal to 11, and our y component right here is equal to 0. So the only velocity of point A is 11 inches per second in the right direction. So our velocity of A is 11i. When we look at this bar AB, we know we're going to have 11i. And we want to figure out what our velocity of B is. So our velocity of B is going to be equal to the velocity of A plus this omega AB crossed with the position vector of B with respect to A. So R B over A. We don't know what our velocity of B is, so let's assume right here we have a positive in both directions. Here's a VB of Y, here's a VB of X. So VBYJ plus VB XI is equal to this velocity of A, which is 11, plus, we're going to assume this is positive. We're going to assume it's rotating this way. So omega ABK crossed with this position from B with respect to A. So we're starting at A, and we're going to B. Now when we do this, we need to use some other pieces of information that we have. We know that this hypotenuse right here is 14 inches, and this is going to be some triangle. What do we know this is? We know that if we start here, this is 6 inches, and up to A is 5. So this right here is 5 inches, just from the geometry of the problem. And we can use SOHCAHTOA, we can use the Pythagorean theorem, whatever works. I ended up using the Pythagorean theorem to find this side of my triangle. So x is going to be equal to the square root of 14 squared minus 5 squared, and this is equal to 13.07. So we're going to have to go down 5 inches and over 13.07 inches. So minus 5j plus 13.07 I. And we just have to compute this cross product right here. We're going to have a minus 5 times an omega AB. K cross j is a minus I. So this negative sign is going to turn into a positive. So we're going to have 5 omega AB of I. And then we're going to have omega AB crossed with a 13.07i, so this is going to be a plus 13.07 j. Okay, so this right here becomes our velocity of b equation. But wait, if we separate our I and j components up, we're going to have three unknowns in two equations. We're going to have an I equation, a j equation. We're going to have an unknown right here, an unknown right here, and an unknown omega ab. So we're going to have to figure out some other equation for this velocity of b, or this omega ab. So let's take a look at this wheel right here. This wheel E. And if we take a look at this wheel, we have this point E, and we have this point B. Well, we don't know much about E. This is what we're going to try to figure out, but we do know on the ground right here, if we have a point E, let's call this F, we know the velocity of point F, the velocity of F is going to be equal 0 because the ground is not moving. So we can figure out what this velocity of B is. This velocity of B is going to be equal to the velocity of F plus this angular velocity of the wheel, which we don't know, so let's assume it's going this way, cross with this position B with respect to F. Now, what's this velocity of B? We don't know, so we're going to assume it's the same positive direction. So a velocity of B xi plus a velocity of B yj is equal to a velocity of F, we set it 0, plus this angular velocity k, E, we don't know what this is, so omega E k cross this position of B with respect to F. Well, how do we go from F to B? We need to go up to E, so this is going to be 6 inches, and we need to go over to B right here, and we're told that B to E is 4 inches, so this is 4 inches. So our B to F is going to be a positive 6j minus a 4i. And if we do this cross product right here, we're going to get 6k cross j, so a minus 6 omega E times I. And then we're going to have a k cross an I. So this is going to be a j, so minus 4 omega E j. Now look at this right here. We have this expression for the velocity of B. And right here we also have the expression for a velocity of B. So what if we substitute this equation right here right up in here. So when we do that, we're going to get minus 6 times omega E I minus 4 times omega E j is equal to 11I plus 5 omega AB I plus 13.07. Did I forget an omega in this equation? Yes, I did. Omega AB. So omega AB j. So now look at this. We have two unknowns. We have this omega E and we have this omega AB. And if we look at our I components, we're going to have minus 6 omega E is equal to 11 plus 5 omega AB. And if we look at our J equation, we're going to have minus 4 omega E is equal to 13.07 0.07 omega AB. So now how do we do this? It's two equations, two unknowns. Let's solve for omega AB. We get omega AB is equal to minus 4 times omega E divided by 13.07. Let's plug this in right here. And when we do, and we solve for our angular velocity of E, we get omega E is equal to minus 2.46 radians per second. So what does this mean? This means this assumption we made wasn't right. It's not going this way. It's actually going this way. And because we're in vector notation, we're just going to leave it right now as minus 2.46. We're still interested in figuring out what this velocity of E is right here. So we now know what this angular velocity is of this last wheel that we're looking for. We know what the velocity of B is because we can substitute this omega E into this equation right here, and we can get velocity of B. I guess I'll just put it over here. The velocity of B xi plus vbyj is equal to, if we substitute this minus 2.46 in right here and right here, we're going to get is equal to 9.84j plus 4 plus 14.76i. And so this is our velocity of B. And when we're looking for our velocity of E right here, we know the velocity of E is equal to a velocity of B plus this omega E, the angular velocity of E, crossed with the distance vector from E to B. Now you might be saying to yourself, well, I know that this velocity of E is going to be only in the I direction. Yes, but let's just prove it. So what's this velocity of VE? We're going to assume it has a positive V velocity in the x direction and a positive velocity in the y direction. So when we do this, we have VE xi plus VE yj is equal to this velocity of B. We know it's 9.84 j plus 14.76 I plus this omega E, and omega E is minus 2.46, so minus 2.46k crossed with this position vector r of E with respect to B and E with respect to B. We know we're going to be going over 4i. Okay, so now we can solve this equation. When we cross this right here, this becomes a minus 9.84j. And look at that. This j and this j cancel out. So this is saying that the only term left is this 14.76 inches per second in the I direction. So there is no j velocity. The only velocity is in the I direction, just like we would have thought.